Alright, here's a video going through some of the questions from the Google form from yesterday, if you did it. And I'm just going to go through the process of how to go through some of these, maybe clarify a few misunderstandings, and hopefully this will answer some questions here, okay? So the first question here says, let me do this real quick. Alright. It says, what are the roots and multiplicities of the polynomial function? Alright. What are the roots? Well, the roots here, right, come from each of these parentheses. If we were to set these equal to 0, right, we would have x minus 2 is equal to 0 and x plus 5 is equal to 0. We know that this is x equals 2 and x equals negative 5. Okay. Then the multiplicities are simply just what's the exponent. For this one, it's a multiplicity of 2. And over here, it's a multiplicity of 7. Alright? That's all it is. Okay. Maybe I might come back to this and show you how we could graph this maybe by hand. But I just want to focus on those questions for now. Alright, so that's number 1. Okay. Number 2, how will the graph behave at x equals 0? So first of all, you have to determine which of these gives you a root or x-intercept at 0. Okay. So we know that this one, if we were to set this equal to 0, then the root is going to be at positive 2. This one is at negative 5. And this one, this is the one at 0. Because if we were to set this equal to 0, then it would just be 0. Okay? Now, what's going on here in terms of the multiplicity? Well, it's a multiplicity of 4. Okay? Now, more than the multiplicity being 4, what's important is that it's even, right? Clearly, this is an even number. Okay? And if you look back at the notes, or if you watch one of Mr. Pardon's videos, when your multiplicity is even, right, this is what we call a bounce back, or a bounce. Okay, so I'm not exactly sure what it might look like, but we know that at 0, right, and for now I'm just kind of making this up. Let's say my curve looks something like, something like this. Then at 0, it's going to hit the 0 and then bounce back. Something like that. Alright? So when it's an even, it's going to bounce back there. Right? Number 3. Yeah, let's do number 3. Okay, so there's one thing I want to clarify from the video, okay? When it's an odd multiplicity, alright, meaning if you have an odd exponent, okay? So there's, like I said, there's one thing I want to clarify, and so maybe I'll clarify with an example here, alright? If you want to write this down, you can, or if you want to just watch, you can do that. And I want you to write down maybe this equation, or this polynomial expression. If you have x plus 4, right, and let's say x minus 3 cubed, okay? Alright, now we know that the roots, if we were to solve these, okay, this is going to be at negative 4, this is going to be at positive 3, and the multiplicity here Now there is a multiplicity, right? What's the invisible exponent? It's 1. And here the multiplicity is 3, right? So if we were to graph this, right, it might look something like this. Okay, at -4, and then at +3, right? Okay, so here's one thing I want to clarify. In the videos, you know, you were told that if it's an odd, it crosses through. Okay, I'm going to be a little bit more specific. When it's a multiplicity of 1, it crosses through. Okay, it does cross through. Okay, but when you have a multiplicity of an odd number greater than 1, okay, when you have a multiplicity of an odd number greater than 1, it does cross through, but specifically, it snakes through it. Okay, and here's what I mean. Again, I'm not sure if you know if this graph is going to be accurate, but let's say so. Here at -4, it's a multiplicity of 1, so it just crosses straight through, right? So something like that. And then we know that, okay, it's going to have to come back down, right? Because it has to hit this 3. So at 3, right, it's going to come back down, but I'm going to erase this and maybe do a better one, okay? Oops. It's going to go through -4, and then it's going to snake through something like that, right? I hope you can tell the difference, okay? So it doesn't just go straight through it, it kind of curves and snakes through it, right? So anytime you have an odd multiplicity, right, it's going to snake through when it's bigger than 1. If it's just 1, it just goes right through it, okay? So let's look at, now it says which of these, but obviously I didn't give you any of the options. And so we're just going to go through what this might look like. And I'm also going to review, in one of the videos, he talks about the most important term, right? And so I'm going to, let me show you, I'm going to pause here and kind of give you some information just to save time. So here I gave you the zeros, right? I solved for the zeros, and I also wrote down the multiplicities. And we also know that for both of these, all right, multiplicity of 1, these are just going to cross straight through the x-intercepts. This one, since it's even, it's going to bounce, okay? It's going to bounce back, all right? One thing I'm going to also do, all right? So I know that, again, if you want to just watch for now, that's fine, right? There are 3 solutions, so these are going to be my 3 x-intercepts. Here at -1, I'm going to try to space these out. This is at -1. There's one here at 0. And then there's another one here at 2. Right? Okay. So then, well, the question is, all right, well, how do we know if it starts up here? Does it start down here? Okay. This is where it's important to know, right? Remember, these are invisible 1, invisible 1. Okay. Now, I'm not going to ask you to do this, all right? But if we were to multiply all of these, if we were to multiply everything out, all right, I know that if I multiply everything out, what's going to happen is, right, if we were to add these exponents, at 1 plus 1 plus 2, right, then the biggest term is going to be x to the fourth. This is your most important term, right, when it's x to the fourth power, okay? Now, why is that important? Okay. The other ones, you might have x to the third or something. You're going to have x squared, but those don't matter as much, okay? Because remember when Mr. Pardun said, okay, what if you substitute in a very large number for x, right? Okay, so let's do that real quick. So for instance, what if you have for x like 10,000, right, to the fourth power? Okay, that's a very large number, right? It's a positive 10,000 raised to the fourth power. That's going to be a very large positive number, which means it's actually approaching positive infinity. That's terrible. That's an infinity sign. Okay, so when x is getting larger, right, the y values, the curve is approaching infinity. So I know that after this 2, because 10,000 is clearly bigger than 2, right, eventually this is going to go in an upwards direction, okay, because it's going towards infinity. Well, on the flip side, well, what about the negative numbers, right? So let's say we plug in negative 10,000 to the fourth power. Well, okay, it's a negative number, but that doesn't mean that it's automatically approaching negative infinity. Think about, okay, it's negative 10,000 to the fourth power. Since that's an even exponent, right? Think about that. A negative number to an even exponent results in a positive number. So this one also is approaching a positive infinity. So over here to the left of negative 1, I know that it's going to go upwards also here, right? So that's the connection to the previous lessons, right? The most important term is the one with the highest exponent. And then you got to think about, okay, when you have a positive large number and a negative large number, right, what's the end behavior? That's why we did the end behavior. So now we also have to do this part, right? At negative 1, right, what happened? It's a multiplicity of 2. So it's going to bounce, right? It's going to hit this negative 1, and it's going to bounce back up, right? Now at some point, it has to come back down again. Now I don't know how high, right? But it doesn't really matter right now. The most important thing is we know that because it has to go through another x-intercept, okay, it has to come back down, right? So, and then what happens at 0? It just crosses. It goes straight through it. Same thing at 2, okay? So it's just going to come back down. It's going to hit this 0. And then see, it has to come back up, right? And so it's going to go straight through and then connect over here with this end behavior. And this is potentially what it might look like right here, okay? So let's try maybe, let's actually try this one, all right? Let's draw this a little bit more accurately. Okay. I have this, right? Here are my x-intercepts. Okay, so these are my x-intercept labeled for you.